All right, guys. Let's try again. Okay, these guys. Anytime you want to do these, it's y equals my laundry and the baby's laundry. So something with the x, and then a number by itself. This is called y equals mx plus b. This goes up by 2. This actually goes down 3. Be careful. That's not very common to have them listed out of order like that. But 2 divided by -3 is -2/3. So that's kind of weird. And again, we start on day 0 in the present. We start with $5. Okay, over here, y equals something, my laundry and the baby's laundry. Let's see, this one goes up $10. This one goes up $5. One way to think about it is -3 needs to go all the way to 0 first, and that's 3. And then it needs to keep going to 2, so that's another 2. So sometimes if you think about the 0 being in the middle, you realize that this is 5 away from each other. Okay, so 10 divided by 5, the slope is 2. This guy's making $2 a day, or this graph is going up 2 boxes every 1 box. And then we don't know, but if you're making $2 a day, right, if you're 2 times x, then after 2 days, you should have $4. But somehow you have 16. So you started with $12 in your pocket. There's this extra 16. So you take your x, you multiply it by whatever the slope is, and this should be your y. If it's not, you need some extra. You guys are really good at that. Okay, slopes. I'm just going to go through really quick. 3. First thing I could say, 3 is going down as it goes to the future. 3 is going down. 4 is going up. 5 is go... Did I do this again? Oh, okay. Nope, 4 is not going up. Wrong line. Okay. 3 is going down. That's line 3. Line 4 is this one doing nothing. He's a do nothing. Line 5 is this one going up. So that's positive. You don't have to write positive, but just so I know I've done it. Line 6 is the stuck in time. We don't even know if that's improving or not. That's undefined. And line 7 is this guy right here, and he's going up. Okay, so how much? Line 3 is going down. He's losing $3, but not right away. It takes him 2 days to do it. So he's losing 3, but it takes him 2 days to do it. Let's see, 5. He's going up $1 every day. If you're doing something every day, that's your score. So he's going up $1 every day. So positive 1 or just 1. And 5. Oh, that was 5. Positive 1. 7 is... Okay, 7 is going up. I didn't number these very well. 1, 2, 3, 4. He's going up $4 every 1 day. If you do something every day, that's your score. So 7's score is positive 4. Once you know the slope, you know a lot of the equation. Y equals my laundry and baby's laundry. My laundry always gets the x. And then something without the x. Now, obviously, if this makes sense to you, you don't need to draw the shapes. This is just knowing that we always need 2 of those. My laundry is extra large. It gets the x. If you know the slope, that's what goes in here. So -3/2. So in the equation, the x is by the -3/2. But it's not actually part of the slope. It's just where you find it. 0, we don't write 1s, and 4. And if you have 0 of something, you don't mention it at all. If you have 1 of something, you just assume that there's a 1 there. You don't have to write it. You just assume it. All right, and then baby's laundry is where does these things start? Not in the future, not in the past, but during the present, right there on the y-axis. So that's, let's see, number 3 starts down here at -1, 2, 3, 4. Number 4 starts down here at -1, -2, -3, -4, -5, -6, -7. Number 5 starts down there at -1, 2, 3, 4, 5. And number 7 is up here at, I can't see anything anymore. Number 7 is up here at +2. So there we are. Y equals negative 3 half of x minus 4. Y equals negative 7. Y equals x minus 5. Y equals 4x plus 2. And then the weird one, the one that's stuck in time, x equals, it starts with the other one. He's stuck in time on the timeline at 1, 2, 3, 4, 5, 6, 7, 8. X equals 8. So those are all the points where the x is 8. 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, 8, 6, 8, 7, 8, 8, 9, 8, 10. Okay, how many solutions? Let's see. This, you just play the game. We really have 4x's plus 6 on this side. Once we do over here we have 4x's minus 7. If you have a situation where the x's are going to cancel out, you have the same amount of x's on both sides, this problem's going to get weird. It's going to be no answers or infinity answers. 7 equals 6? No, 7 does not equal 6 ever. There is no solution to this. 6x plus 2 equals 6x plus 2. We have 6 x's. We have 6 x's. When they're the same, they cancel each other out. 2 equals 2? Yes, forever. Infinity answers. Over here we have 4x's plus 2x's, so we really have 6x's minus 2 on this side. We really have 6x's plus 9x minus 2 on this side because we have 6x's and 3x's. Those will not cancel out. Those 6x's and 9x's don't cancel each other out. Nothing's going to get weird about this problem. It's just going to have a normal answer. I don't know what it is, but it's going to be normal. Over here we have 6x's and negative 6x's. Those aren't the same number. It has to be the same number. So these do not cancel out. Nothing gets weird. This is just going to be a normal problem. Over here, let's see. Here's hi. Here's hello. I'm going to take out hi out of that equation and replace it with hello. So 2x minus 4, 2x minus 8 equals 14. All right, so let's see. 2x's minus 8x's plus 32 equals 14. So 2x's minus 8x's is negative 6x's plus 32 equals 14. Minus the 32, minus the 32, and negative 6x's equal negative 18. Divide by negative 6. X's equal positive 3's because the negatives cancel out. So positive 3 is what x is. So if x is positive 3 in my head, I can do 2 times 3 is 6, minus 8 is negative 2. So I could do y equals 2 times 3 minus 8. Y equals 6 minus 8. Y equals negative 2. Okay, next one. Let's see, I'm going to multiply this one by negative 3 to get the x's to be negative 12x's minus 9y's equal negative 27. So when I do these, 12x's minus 12x's, no x's, negative 9y's plus 9y's. Ooh, we have nothing on this side. Okay, so everything canceled. Negative 27 plus 24 is negative 3. 0 does not equal negative 3. There are no letters in this, so this is like a situation back in number 8. This is no solution. All right, over here. In these, I think we did this in class, but this is a blue angle. This is a blue angle. Those are vertical angles. If you have an intersection, the opposite angles are the same. The ones right next to it, because it makes a straight line, the blue angle and the red angle must add up to 180. So a blue angle and a red angle add up to 180. But this also has to be a red angle, A, because there's a straight line this way, but also because the red angles are across from each other. Those are vertical angles. Anytime you have two parallel lines that is cut by the same line, up here we have a red and blue intersection, down there we have a red and blue intersection. So those are the same intersections. So the same angles are going to be the answers. So this is going to be a blue, this is going to be a blue. These are called corresponding angles, red and red. Okay, so red, blue, blue. Okay, this is pretty tough, but we look for something that we can compare. And we can't compare other angles yet, but we can compare x's. So over here, this angle has x's, and over here, this angle has x's. So we can compare those. One's a red angle, one's a blue angle, and we know those are reds and blues are supplementary. So this angle, 2x minus 20, if I add it together with this red angle, x minus 40, that equals 180 degrees. And these setups, any red and any blue adds together to 180. If they were both blues, they'd be equal to each other. So then we say, okay, we've got 2x's and 1x's. We have 3x's. We have minus 20 and minus 40. We have minus 60 equals 180. We're going to add 60, and 3x's equal 240. Once we divide by 3, we know x's are 80s. So far, x's are 80s. Okay, I can plug in x is 80. So if x is 80, then this angle up here, 2x minus 20, that's 2 times 80 minus 20. That's 160 minus 20. These blue angles are 140 degrees. So everywhere there's a blue angle is 140. Which means every red angle is 40 because they have to add up to 180. So every red angle is 40. And yeah, remember how x's were 80s? 80 minus 40 is 40. So every red angle is 40. So that means 40, 3y plus 1 is actually 40. 3y plus 1 is 40. So we're going to minus 1, minus 1. 3y's is 39. Divide by 3. Y's are 13s. And we also know 1/2 of z plus 10 is also 40. So we're going to minus 10, minus 10. 1/2 of z equals 30. To get rid of fractions, we do the upside down, a 2 to kill a 2 and a 1 to kill a 1. So that's really just multiplying by 2. So over here, we're multiplying by 2 once, or just 2. And z equals 60. Over here, a triangle has 180 degrees. So if I add up this angle, and this angle, and this angle, that's 180 degrees. So 2x's plus 3x's plus 7x's is 180. So that's 12x's equal 180. When I divide by 12, x's are 15s. Now, that doesn't mean the angles are 15. So this angle is 2x's, so that's 2 15s, that's 30. This angle is 3 15s, that's 45. This angle is 7 15s, that's 105. And if I add those all together, yeah, they equal 180. So that's good. But down here, we have a straight line. Down here, we have a straight line. We have 105 degrees right here, and we need to know how much it takes to get all the way to 180. So that's why it's at 75 degrees. And there's this shortcut in math. This is called an outside angle on a triangle. An outside angle will always be equal to, if you want a shortcut, the other two angles on the inside on the opposite side. So you see how 30 and 45 is 75? This will always be 75 on the outside because they both need 105 as their partner to get to 180. That makes sense? Great. If not, just do it the long way. We have straight lines that add up to 180s. We have triangles that add up to 180. Okay, let's see. X to the n power times x to the third power is 7. So we know our powers rules. This has to be a 4, right? Because 1 less than multiplication is addition. So how did we get to 7? We must have had a 4 because you just add the powers. So n equals 4 in this one. All right, let's see. X to the n divided by x to the negative 2 equals x to the 5th. So it needs to be n minus negative 2 equals 5, right? Because we do subtraction. This one's subtracted by negative 2. So actually, n plus 2 is 5 because subtracting a negative 5, or subtracting negative 2, a negative of a negative. We minus 2, and n needs to be 3. So this number needed to be a 3. So x to the third, 3 minus negative 2 is 5. All right. In powers of powers, 1 less than powers is multiplication. So 3 times n is how we got to 6. So we divide by 3, and n was 2. That's how. So it's just another way to ask you the power rules. Over here, you can do this first, the parentheses around everything. You can do powers of powers, so multiply all of this. You can do that first. I tend to do it last, but it doesn't matter. Meaning, down here, 1 less than multiplication is addition. -3 plus -2 is actually a positive and a negative is -3 minus 2. So this is actually 3 to the 12th over 3 to the -5th. Okay, now if we're going to continue that, we're going to do 1 less than division is subtraction. So 12 minus -5. 12 minus -5, that actually makes it a positive. So now we have 3 to the 17th. And then we have all of that to the second power. So we did everything inside, and then we did the second power. This equals 3 to the 34th. I could have done that another way. I could have said, hey, I'm going to take, this means everything to the second power. So multiply everything by 2. One less of powers is multiplication. So you could have said this is 3 to the 24th divided by 3 to the -6 times 3 to the -4. 1 less than multiplication is addition. So this could be 3 to the 24th over 3 to the -10th. And then 1 less than division is subtraction. So 24 minus -10 is 34. Either way, we get 3 to the 34th power. All right, in scientific notation. In scientific notation, you can do, there is a shortcut for multiplication for powers. 1 less than multiplication is addition. So there is a shortcut over here. We can just add those, and this is 10 to the 6th power. So we've got something times 10 to the 6th. These are normal numbers. We can do normal multiplication. That's just 15. But this number is not scientific notation. Technically, this number is 15 with, move the 1, 2, 3, 4, 5, 6, where we move the decimal over 6 times. But if I was going to put that in scientific notation, I would make it 1.5, put the decimal after the first number, and then move it over 7 times. So you can't have a number be bigger than 10 right here, if it's or smaller than 1. If it has to be between 1 and 10, so the decimal has to be after the first. So basically the shortcut is make it 10 times smaller, but make this 10 times bigger. And that equals it out, evens it out. All right, in scientific notation, can we add these? Well, 1 less than addition is nothing, so there's no way for me to shortcut this multiplication. There is no way, 10 to the 2nd plus 10 to the 3rd, I don't know what that is. Like, there is no way to just shortcut that. So I have to turn these into normal numbers. I have to turn 6.1 and move the decimal over 1 2 times, so this is 610. I have 3.5 and move the decimal over 1 2 3. This is 3050 plus 610 is 0 1 1 4110. But it says in scientific notation. So this is 4.11 times 10 to the 3rd. So you put the decimal after the first number and say, I would have to move it over 3 times. Okay, what are the distance? Earlier in this, we said the distance between a negative and a positive. You can do subtraction. You can do this in your head. -2 takes 2 to get back to 0 and 3 to get to 3. So these are 5 apart. These are 2 apart. And we're going to square them. We're going to do a squared plus b squared equals c squared. This is 25 plus 4 equals c squared. This is the square root of 29. Okay, so the square root of 29, I don't know that, but I know the square root of 25, and I know the square root of 36. I'm 4 away from here. I'm 7 away from there. A good guess would be somewhere between, okay, obviously between 5 and 6. Probably, it's definitely on this side, probably like 5.3-ish, somewhere in that neighborhood. Over here, anytime you see hundreds, you're probably going to use the number 100. So the pink number that we want to use for this one is 100 times 11. That's how we get to 1100. The answer for the pink number of 10 is 10. So this is 10 times the square root of 11. This one, I'm not going to use 25. I am going to use 16. So this is 16 times the square root of 16 times the square root of 2. And the square root of 16 is 4. So this is 4 times the square root of 2. All right, we have two numbers. How many times larger? When you're saying how many times larger is a number, you're dividing. When you're like, if I'm 200 pounds and someone in class is 100, I'm twice as big. 200 divided by 100. So we're dividing. How many times larger is 9 times 10 to the 5th divided by 3 times 10 to the 3rd? Yes, there are shortcuts for division because 1 less than division is subtraction. 9 divided by 3, normal numbers, normal division. Powers rules, powers division. 1 less than division is subtraction. So this is times 10 to the 2nd power, 5 minus 3. And I can leave it as that my answer, or 3 times 10 to the 2nd, move it over once. This is 300 times bigger. How much bigger is it? Well, if I'm 200 pounds and someone else is 100 pounds, I'm 100 pounds more. 200 minus 100. So let's do the same thing. 9 times 10 to the 5th minus 3 times 10 to the 3rd. Unfortunately, there is no shortcuts for minus with the powers. 1 less than minus is nothing. So we have to take these all the way to numbers. 9, 1, 2, 3, 4, 5. This is 900,000. 3, move it over 1, 2, 3. This is just 3,000. So 0, 0, 0, 7, 9, 8. 897,000 is the answer. And if you leave it as that, that's fine. If it says in scientific notation, then we turn it back to, you put the decimal after the first number, and we turn this into 8.97. But we'd have to multiply 1, 2, 3, 4, 5 times. So times 10, 5 times, or times 10 to the 5th. All right, hopefully those all make sense. If not, hopefully more of them make sense than 2 days ago. And good luck.